Hello class. Today we're going to cover section 6.4, the hyperbola. Here's a definition for it. A hyperbola is a collection of all points in the plane, the difference of whose distances from 2 points, called a foci, is a constant. So any point along the hyperbola, if we subtract its distances to each of the focal points, they should be constant throughout. Now, along the main axis that goes through the vertex and the foci. That's going to be called the transverse axis, and the one perpendicular to it that's going through the center is called the conjugate axis. There is a theorem that you will need to know, and one thing that's important about this theorem is that your C is found with the foci, and your A is found with the vertex. And then here are two equations that we're going to be using throughout when we have a transverse that's going through the x-axis. So let me go ahead and show you an example so you guys can do and understand these problems. So here we go. So in this problem we can see that our C is 3 because it correlates to the focus, and our A is 2 because it correlates with the vertex. So we're going to go B squared is equal to C squared minus A squared from the equation that we have. So B squared is equal to 9 minus 4. B squared is equal to 5. So B is equal to plus or minus the square root of 5. One of the things that we can do is we can actually plot some points, and it's going to be useful for us. So we know that plus and minus 2 is going to be where the vertex is going to occur. And another important point that's going to be useful, and actually before I finish, let me just write the equation. So it's going to be x squared over 4 minus y squared over 5 is equal to 1. Now, one of the things that's important here is because the x squared is the positive, this is going to be the transverse axis. And so we know that the hyperbolas are going to open this way. One of the things that's neat about this is it also gives us a lot of information. So this bottom number 4, if we take the square root of that, that's going to be the distance along the transverse from the origin. If we take the square root of the 5, square root of 5 is 2.23. That's going to be right about here and here. And that's going to be the distance from the center for the conjugate. So one of the things that's neat that we can do is if we create a box along these 4 points, the vertices along the transverse and the conjugate y values, we end up forming this box. And from this box, what we can do is we can create our asymptotes for our hyperbola. And so it's pretty neat because it makes it so it's going to be quick for us to be able to graph this thing. And so again, this was the square root of 5. This is negative square root of 5. This is 2, and this is negative 2. Those numbers all relate to this equation here, and it's just the square roots of the denominators of those functions. Now, in order to graph it, since we know it's a hyperbola, it's going to follow along the axes. And I don't even need to plot other points because I know it's going to follow this thing here. But those asymptotes are very important. And so the asymptotes are just basically y is equal to the square root of 5 over 2, and y is equal to negative square root of 5 over 2 to get the two blue lines that create the asymptote. Excuse me. So let me do another example so you guys can see. Here's this one. And so again, we see that this is going to open along the from right to left. And the reason it opens from right to left is because the x squared term is positive. And so we know it's going to be at the origin. Because it's 16, square root of 16 is going to give us plus and minus 4. And that's where the vertex is going to occur. And then we know that the square root of 4 is plus and minus negative 2. And so we can create that box again that we had. And so that box that we get is going to go just like this. And right where those corners are is where we're going to create our asymptotes. Now you guys can actually test this by using a calculator to graph it, but this is just a very quick, easy way to do it. And so we can see, we know that the center of this thing is at 0, 0 because there is no h or k. We know that the vertex is occurring at plus and minus 4. Again, because the x term is positive. And so we know a squared is 16. B squared is 4. So let's see if we can find out where the foci are. So that's going to be b squared plus a squared. So c squared is equal to 16 plus 4. C squared is equal to 20. And so c is equal to plus or minus the square root of 20, or 2 radical 5. And 2 radical 5 is just shy of 5, and so the foci is right there. Oh, I didn't draw it on the previous function. I can draw that for you guys so you guys can see. So this thing's going to go like this, and like this, and like this, and like that. And there's that one. Going back to this one, I didn't give you the foci. It was there, but I didn't plot them, and there they are. In fact, let me make them red so you know. Right there and right there. Right. Let me do another example for you, but now this time let's make the transverse angle along the y-axis. And so instead of opening right and left, this is going to open up and down. And again, we know that C is correlating to the foci, so C here is 3. My A is correlated to the vertex, and that is at 2. And so at plus and minus 2 is where the vertex is going to occur. I'll use red for the foci. That's going to be at plus and minus 3. And so what we need to do for this problem is we need to come up with an equation for it. But before we can come up with the equation, we have to find out what our b is. And so b squared is equal to c squared minus a squared. So b squared is going to be equal to 9 minus 4. Or b squared is equal to 5. So b is equal to plus or minus the square root of 5. So this one's very similar to the first example we did. And remember, square root of 5 is like 2.3. And I'll use orange for that. And again, we want to make that box with the vertex and the conjugates y values, the points that go through the y values of the conjugate, to form our box so that we can create the asymptotes. So we're going to go corner to corner, right? And then corner to corner. And so remember, this was radical 5, this was negative radical 5, this is 2, and this is negative 2. And so this equation here is going to be y is equal to, it's rise over run, so it's 2 over radical 5x. And this one's going to be y is equal to 2 over a negative radical 5 over x. And so we see we get our, I'll rewrite that, I'll write it so it's not over the, so we're going to get 2 over negative radical 5x, and we can see we get the positive and negative values there. Now, in this equation, it's going to open up and down, and so we know that it's going to follow this thing going this way, and then extend this way, and then going down, it'll go this way, and this way. And again, the equation that we're going to get is y squared over our a squared, so that's 4, minus our x squared, and then our b is 5, so b squared, or square root of 5, so our b squared is 5, and there we go. So one of the things when we're writing our asymptote equations, it's just going to be the negative square root of 5 over 2. So it's the negative values, the 1 over the negative number. So in this case we have x squared, it's negative. So the denominator, the square root of the denominator, divided by the square root of the y squared's denominator, which is 2. So that's how I get these values. I actually spoke that wrong. It's the y over the x. So it's the square root of the y, so square root of 4 over the square root of 5, which gives me that equation value. Sorry I misspoke that, but here's a clarifier. Here's the theorem so you guys can always see it. Sorry I misspoke it. It's always going to be y, whatever's under the y squared value, it's square root over whatever's over the x squared's value, square root. Or this might be easier to read and understand than what I just said. So take a minute to write this down. I think this will be useful to have for the exam going forward. Let me go ahead and do another example for you where we have to manipulate a little bit. So in this example here, we're going to have to manipulate it in such a way that we get it to be fractions. So I'm going to take my 9 and divide everything by that 9. So I'm going to get this right here, and then that's going to become x squared minus 4y squared over 9 is equal to 4. And then to get rid of the 4 with the y squared, I'm going to divide everything by that. And so that's going to give me my 1. This is the equation for our hyperbola. And so this is useful. The center is still 4. Our distance is 2 away. Our conjugate is 3 away from the origin, and so when we make the box, we have that drawing from diagonal to diagonal. We know it's opening from left to right because the x squared term is positive. And I'll just write this equation. So it's going to go up 3 over 2. So this is going to be 3 over 2. This one's going to be a negative 3 over 2. Those are the equations for the asymptotes of this. And then we need to find our focal point, and we could easily do that. But we know that this thing's going to open from right to left, just like this. And I'll leave it to you to find the focal point, because we have, in this case, we do have our A and B. To find our C should be quite easy. Okay. When we don't have the center at the origin, and we have some manipulations, here's how we do it. Let me go ahead and show you with this example. And again, it's going to be a completing the square issue that we're going to have to do. And so I'm going to rewrite this in such a way that I have the x terms together and the y terms together, and then I'm going to move the constant to the other side. So I'm going to get negative x squared minus 2x plus 4y squared minus 16y is going to be equal to a negative 11. Now what I'm going to do is I'm going to factor out a negative, so I'm going to get x squared plus 2x, and then half of 2 is 1, that squared is 1. I'm going to factor out a 4 from the y term, so I'm going to get y squared minus 4y. Half of negative 4 is 2, that squared is 4. And so I need to add some numbers on the other side, or maybe add some numbers, we'll see. Here I added a 1, but really what happened is I subtracted 1 because of the negative sign. So I'm going to have to subtract 1. Here, it looks like I added 4, but I'm multiplying it by a 4. So I'm adding 16 to that. Now, cleaning this up, this is going to be a negative x plus 1 quantity squared plus 4y minus 2 quantity squared is equal to a positive 4. Now, I'm going to divide by that 4 that's in front of the y minus 2 squared term. So I'm going to get a negative x plus 1 quantity squared over 4 plus y minus 2 quantity squared. And I'll just write over 1. And then dividing that 4 by 1, I'm going to get this. Now from here, what I get to see is that the center is going to occur at negative 1, 2. So I'm going to plot that point. So this is the x-axis, this is the y-axis, and we can see that this thing's going to open up and down, and the reason it's going to open up and down is because the y term is the positive. So it's going to open up and down because of that. So 1, negative 2 is right there, that's the center. My x, since we have a 4, square root of 4 is 2, so we need to go 2 over to the right and 2 over to the left. And then to find our y terms, we're going to go up 1 and up 1. And so, in fact, I'll do those as I'll do them as orange. This and this are the vertices for this parabola that we're going to do. Now, we're going to go ahead and make our box, and I'll do them blue, so I can create my asymptotes. And so the asymptotes are going to go in this direction. And since we know here that it's opening up and down, our hyperbola, our hyperbola is going to be going just like this. And again, for you to find the foci, you have your A, you have your B, you should be able to go get your C. Here are the formulas that you would use to go ahead and find that. But these are the graphs for it. I hope you found this beneficial. As always, all the best.